Today we're going to look at how to solve radical equations. We've talked about a lot of properties of radical expressions, and now we're going to look at equations involving radicals. So equations that have variables within radicals are known as radical equations, believe it or not. There are three kind of basic steps we're going to follow. Obviously, the complexity of these steps can change depending on the given factors of any equation, but first what we want to do is isolate the radical on one side of the equation, meaning get the square root part by itself. Then we will raise both sides of the equation to whatever exponent is necessary to eliminate the radical. So if it's a square root, we're going to square both sides. If it's a cube root, we're going to cube both sides. We got to do the opposite of whatever root we're looking for to eliminate that radical. And then third, we'll just solve whatever's left over using whatever tools and techniques we've talked about previously for solving equations. So once we eliminate the radical, it's basically do whatever we have to finish solving the equation. Okay, so first, let's just look at the one on the left. 2 times the square root of x plus 1 is equal to 4. So, get my pen here. We're going to get the radical by itself, which means I'm going to divide both sides. Oops, nope, got to have a pen. Okay, that's too big. By 2. So on the left, those will cancel, and we'll have just square root of x plus 1. And on the right, we will have 2. Now, step 2 from our previous list is to raise both sides of the equation to the same radical, or to the same exponent, excuse me. So we've got a square root here. So to undo a square root, we need to square it. So whatever I do to the left, I got to do to the right. The square root and the square cancel, and I'm left with x plus 1. 2 squared, or 2 to the second power, is 4. Step 3 now is to just finish solving the equation. So I want to get rid of the 1. I got to subtract it from both sides. X is equal to 3. Okay, so if we think about the 3 steps from before, this would be step 1, isolate the radical. Step 2, raise both sides of the equation to the same power. And step 3, solve the equation. Okay, so let's jump to the other one. This one's a little more complicated. It's a cube root. That'll be important in a second. So I want to get the radical, which is this part, by itself. So I'm going to add 1 to both sides. So I have the cube root of 2x minus 9 equals 3. Now I'm going to raise both sides to some exponent. I don't want to square it this time, though. This is the cube root, so I need to cube both sides of the equation. Right? These will cancel, leave me with just 2x minus 9 over there. So the radical's gone. That's what I wanted. 3 to the third power means 3 times 3 times 3. So 3 squared, or 3 times 3 is 9, times another 3 is 27. Then I'm going to add 9 to both sides. So 2x is 36. X has to be 18. Okay. After we solve, we want to go ahead and check both of those. So I need to take, in the case of the left equation, this 3 and plug it back in for x. And on the right, I'm going to take the 9, or the 18, excuse me, and plug it in for x to make sure that they still work. So that's what we've done here. Plug the 3 in. 3 plus 1 is 4. Square root of 4 is 2. 2 times 2 is 4. It works. On the right-hand side, 18 times 2 is 36. Subtract 9, I get 27. Cube root of 27 is 3. Minus 1 is 2. It works also. Notice we have these question marks above the equal sign until we have verified that the two sides are in fact equal. But once we know that those work out, we know that we had the correct solutions. Okay, here's one application of radicals. We've also talked about how they relate to pendulum length. Another application is in meteorology. Mean sustained wind velocity is a measure of strength of hurricanes. It's one way to figure that we describe how strong a hurricane is. And we use this equation to model that. So velocity is equal to 6.3 times the square root of 1013 minus p, where p is the air pressure in millibars at the center of the hurricane. I do not know where the 6.3 and the 1013 come from. I would imagine if you get a degree in meteorology, you would learn that. We're just going to use the equation. So our task is to estimate the air pressure at the center of the hurricane if the sustained wind velocity was 54.4. So the problem is what we've been given is not p, right? P is what I want. I know this thing. So I know that 54.4 is equal to 6.3 times the square root of 1013 minus p. And p is what I'm looking for. So we just need to solve this equation. And so you can imagine this might happen if a hurricane's coming through and they're able to measure the wind speed on the outside of the hurricane, but they may not know what the air pressure is, and this is how they would figure that out. So I'm going to take the 54.4 and divide it by 6.3. So we're dividing both sides by 6.3. On the right, 6.3 just cancels. On the left, we're going to have 8.63, keep it to the nearest hundredth, is equal to the square root of 1013 minus p. Okay, so now I square both sides to get rid of the radical. I'm going to square because I'm looking for the square root, so I want to undo the radical. On the right, 1013 minus p, and on the left, that number squared should be 74.56. I'm going to subtract 1013 from both sides to get the negative p by itself. Those will cancel. Over here I just have negative p. We'll deal with the negative in a second. And we're going to have negative 938.44. They're both negative, so I can make them both positive by multiplying by a -1. So p would be 938.44 millibars. Pressure at the center of the hurricane. Oh, I just gave myself some work, I guess. So let's solve this guy. Remember, first step, isolate the square root. Well, if we notice, square root is by itself, so that's good news. Now we just need to square both sides. Now this gets a little bit different, though, because what I'm squaring on the left is not just a number, right? So when I multiply x plus 1, or when I square x plus 1, what that really means is x plus 1 times itself, right? It's not x squared plus 1 squared. So we got to distribute. X times x and x plus 1 is x squared plus x. Then 1 times x and 1 times 1 is going to be x plus 1. So I'm really getting x squared plus 2x plus 1. So that's my left. X squared plus 2x plus 1 equals 7x plus 15, right? Because the square and the radical cancel. They undo each other. They are inverses of one another. Now I just need to solve what's left. Well, this is a quadratic equation, I can tell, because it has an x squared in it. So I want everything equal to 0. So I'm going to subtract that other stuff. X squared minus 5x, 2x minus 7x. And then 1 minus 15 is negative 14 equals 0. So this is where I would try to factor first. If factoring doesn't work, we can complete the square or use the quadratic formula. You could skip to those if you'd like, but I always try to factor first, because if something is factorable, this is going to be the fastest way. So x and x. Factors of 14 that add up to 5. Well, factors of 14 are 1 and 14, or 2 and 7. Hey, those can give me a 5. I need a -7 and a +2. That gives me a -5 when I add them. And then -7 times 2 gives me the -14. So that's what I want. Then they both get set equal to 0. X could be 7 or x could be -2. And that all seems fine and dandy, but we have an enormous problem. Let's go back to the original equation here just for a second. I'm going to ask let me erase, I guess, what I have up here. What is the degree of this function, the way it is? What's the degree of that function? Meaning, what's the highest power exponent that we have? I've got x to the first power. This is x to the 1/2 power, right? Because it's the square root of x. So x to the first is the highest power. So this has a degree of 1, which means we should have one solution. However, this is the equation I solved, and it has a degree of 2. So this has 2 solutions, which we can see. There's one and there's the other. I have added a solution to this equation that was not there before. Right? So what we call these are extraneous solutions. Okay, and we have to check for extraneous solutions. In solving this, I increased the degree of this function, which means it's going to have 2 solutions, when the original function that we were given only had 1 solution. So I need to plug in the 7 for x, and then plug in the -2 for x, and see which of these 2 values will not work. Okay, so that's what I've done here. 7 plus 1 equals square root of 7 times 7 plus 15. So on the left we get 8, and on the right we get the square root of 64, which is 8. So 7 works. If you look at the -2, when negative 2 is plugged in for x, I get negative 1 on the left side, and then the square root of 1 on the right side. Now, I know that one of the possible square roots of 1 is negative 1, but if we were not told to use plus or minus, we're always talking about the principal root. So in this case, it needed to be positive, and it's not. When do you ever take the square root of something and make it negative, right? It just doesn't work. So my negative 2 from back here, this is not the solution. 7 is our only solution. Okay, so raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These are called extraneous. Okay, so whenever you use this procedure to solve, meaning you have to raise both sides of an equation to a new power, you should always check each what we call apparent solution in the original equation. So these are apparent solutions right here because they appear to be solutions. They are solutions to this equation. So if we plugged them into this guy, it would work 100%. The problem is this is the function we're trying to solve up here. So we need to plug them into the original function. Okay. So take a second, put any of this down in your notes that you need, and then we're going to move on. So you can pause. Otherwise, we're going to keep going. So let's solve this one. This one kind of ups that difficulty one more level by having 2 radicals. It's not impossible by any means, but it does increase the difficulty. Think back to step number 1, right? Isolate the radical. That's not going to work if we have 2 of them. This one is isolated, so we'll just go from here. It's just going to introduce another issue, which you'll see in just a second. So we're going to square both sides. That will eliminate this, so that over here I just get 3 minus x. Okay, but over here I have 2 terms. This is a binomial being squared, which means what I'm really doing is taking the square root of x plus 2, oops, x plus 2 plus 1, and multiplying it by itself. So square root of x plus 2, let's do this in a different color. Square root of x plus 2 times square root of x plus 2 is just x plus 2. I'm basically multiplying it by itself, so I'm squaring it. Then I take square root of x plus 2 and multiply it by 1. I'm going to get square root of x plus 2. Okay, I'm going to change colors. And we'll do this guy. 1 times x square root of x plus 2 is going to give me another square root of x plus 2. And then 1 times 1 gives me a 1. So when I combine all of this, what I end up with is x plus 2 plus 2 times the square root of x plus 2 plus 1. 1 plus 2 is 3, so this can become x plus 3 plus square root of x plus 2, or 2 times the square root of x plus 2. That's my left side. When I square this, this is what we get. And over here on the left is the reason why. Now we have to start over, and I want to isolate my new radical, so that guy. Okay, so let's subtract 3 from both sides. Those will cancel. Oh, look, these will cancel also. That's nice. We'll subtract an x from both sides. Over here, those will cancel, which means I'm left with 2 times square root of x plus 2. And on the right side, negative x minus x is negative 2x. I'm going to divide both sides by, oops, let me just change that. This is negative 2x. Divide both sides by 2. This gives me x plus 2. And on the right, I get negative x. Now this radical is by itself, so let's square it, which means I square this also. X plus 2 is equal to negative x times negative x is a positive x squared. Here's a quadratic equation. I just need to solve that. So x squared minus x minus 2, I'm putting both of these on the other side of the equation, is equal to 0. So if I try to factor that, which is going to be always going to be my go-to, just because it could be faster, x and x, factors of 2 that add up to 1, how about negative 2 and positive 1? So x minus 2 could be 0, making x 2. Or x plus 1 could be 0, making x negative 1. These are my 2 apparent solutions. Right? We need to plug both of those in to see which one works, which I've done here on the next page. If I plug in the 2 to the original equation, meaning this thing up here, not the quadratic, if I plug them into the quadratic equation right here, they will work. because they are both solutions of this. The problem is I need to plug into this original equation. Okay, so we plug them into that. So square root of 2 plus 2 is the square root of 4, which is 2. Add that to 1, and I get 3. 3 minus 2 is 1. Square root of 1 is 1. 3 does not equal 1, which means 2 is not our solution. Jump back over here. Plug in negative 1. Negative 1 plus 2 is 1. Square root of 1 is 1. Plus 2 is 1. 3 minus negative 1, that's 3 plus 1 is 4. Square root of that is 2. This one works, which means that this guy is the actual solution. X equals negative 1. Okay. Again, that's because the degree of this function only gives us one equation. The degree of this function, or gives us one solution, excuse me. The degree of this function is 2, meaning we're going to have 2 solutions. We don't want both. Okay. So let's look at this one real quick. This one's a little bit bizarre. We're raising something to the 3/4. So I'm taking the 4th root and cubing it. It might be easier to write it like that. So let's go ahead and do that. The 4th root of 2x, and we're cubing that whole thing. That's one way to write this, right? So let's just start simplifying. I'm going to subtract 2. That seems very easy. 4th root of 2x, and I could actually write that as cubed either way. These two things right here are the same, however you want to write that, equals 8. The benefit to writing it this way is I can raise both things to the 4th power. So I end up with 2x cubed equals 8 to the 4th. 8 times 8 times 8 times 8 is 4,096. Huge number. Okay, but that's okay. 2x and the whole thing is cubed means this is actually 2 cubed x cubed, or 8x cubed. So if I divide 4096 by 8, we end up with 512. X cubed is equal to 512. Then we just need to know what the cube root of 512 is. If I take the cube root of both sides, and you can do that on the calculator by just doing 512 to the 1/3. Your phone calculator can do that even. X has to be 8. The other way to think about this is leave it as the rational exponent. So 2x to the 3/4 is equal to 8. I'm subtracting the 2. I need to raise both sides to the same exponents, right? So the question is, what exponent should I raise this to so that I eliminate the 3/4? Well, when I raise a power to a power, I multiply, and I want this to have a power of 1, so I just need to multiply by the reciprocal. So if I raise the power 4/3, these two become just a power of 1, and I get 2x, and over here I have 8 to the 4/3. Well, 8 to the 4/3 means the cubed root of 8 to the 4th, right? It's bad parentheses. Cube root of 8 is 2, so this means 2 to the 4th. So 2x is 2 times 2 times 2 times 2. It's going to be 16. Divide both sides by 2. And x is 8. Same as what we had over here. I have no idea which one makes more sense to you. You can tackle it either way. This is another perfect example of where there isn't necessarily one correct way. It's just which makes the most sense to you, and which order do you want to apply these tools to get to the same place. Okay, you can rewind and or pause here if you want to take another look at this stuff. If you're confused, feel free to ask me questions. Otherwise, you're on to the homework. Have a good day.